January the 18th, 2017. Guys, you're looking at images of Earth from Cetier and Comet Honda. Now, we'll bring this closer, but I wanted to kind of show you the wider image here. We're going to go through several different images. But if you drew a line coming right under the word Earth, which is superimposed next to our planet that you see there, Comet Honda is coming in very fast. Now, we'll look at it closer, but if it comes in and almost appears to be above our planet, and I'll slow it down. But as it comes in, guys, we'll stop it. Notice the comet tail on it. It's about to come into the bottom part of the H. It's going to go through that, go through the T, go through the R, through the A, and through the top corner of the inside part of the E. Check that out. We'll look at it again. There it comes. It's got a tail. Now, also, Cetier images, backside of the sun. That is Comet Honda. The dot you see is Earth. Now, the reason I'm showing this is because I'm tying in about 2 or 3 different things into cosmic and solar radiation that's increasing on our planet very drastically. As I back that out again, the Earth and Comet Honda coming above us. The sun is to the left. The reason I want to show this camera is because of the energy coming from the sun directed at the comet, which is approaching our planet. So from day one, when we started talking about Comet Honda, I said what we need to be concerned about is the reaction between it and the sun as it comes in alignment with the Earth. Now, stereo A, and that's what we saw the last few images of Honda from, guys, is in the same orbit as Earth, but it's on the other side of the sun, not directly behind it, but offset, and it's looking at Venus and Earth depending on which camera. And so I superimposed the location in the red dot on the left of Honda. But on the right, guys, is the Honda diagram itself. Now, it looks like it's going above the Earth now simply because of the angle between stereo A in the top right and Earth. But they're going to rendezvous February the 11th, where the green and yellow era meets as it comes right above the Earth. That's the closest approach. While we are on stereo A, notice today's date, the coronal hole that we saw just leave from our side of the sun, causing the almost 800 kilometer per second solar winds, is still very active. Now, we've been watching as we switch to SDO satellite images, which gives us our side, or the Earth-facing images of the sun. That large coronal hole has been affecting our planet. The solar wind speeds have went over 600 kilometers per second. But these 2 sunspots are creating a magnetic canopy. And when you have a magnetic canopy, the coronal hole normally releases energy straight towards our planet if it's Earth-facing. In other words, it's like a clear day on the sun. But with a magnetic canopy, these loops that you see between these sunspots get that energy and transfer it back into the sun. Now, one of the things that happens here during that blur is we're actually seeing a filament release above these sunspots. It creates a V right at the very top, blurs the satellite, and creates a Hyder flare. Now, remember, we've seen very few days with sunspots at all in the last several months. Now we have a group of 2 different sunspots. And when they came around the sun, guys, they were both magnetically configured as alpha. Notice this. Now the 2626, the larger group, has went to beta. And the lines are the magnetic lines that are creating this canopy and capturing the solar wind, which is going to slow it down some, are feeding back into these sunspots. We're going to have to watch them. Now, what are the effects on our planet? Earthquakes from the pressure, increased volcanic activity, and remember in last night's video, if you didn't see it, guys, go check it out. Mutation of the reproductive cells in humans. But the yellow arrow is pointing towards Italy, and you've got the convergence of the Arabian plate, the Eurasian plate. Notice that point right there at the boot of Italy. That's a spike or a bend or a pressure point in 2 massive plates. Now, quick look at our shields, the magnetopoles. The red line is the average at 12 as far as standoff, but today, guys, our shields collapsed into the satellite band. That's only 22,400 miles above our planet. Also, solar wind speed doubled from last night at 300 kilometers per second to over 632. Now, the density at 7.2 protons per centimeter cubed, that's strong at that wind speed. But last night, guys, check this out. As this was building, wind speed was only 334 kilometers per second, but one of the highest proton counts I've seen at 42, but it peaked at 50. If you look at the Discovery satellite, the gray line indicates where we're at, and it had dropped to 34.78. But just behind it, at that peak, we were near 50 protons per centimeter cubed. Extremely strong, very rare to see that much energy. And what does that do? Cosmic radiation. Let's look at a 10-day panel from around the planet. Top, Greenland. We saw a peak. Notice the timestamp between the 18th and the 19th. This is counts per hour. This is cosmic radiation. It can cause genetic mutation in your reproductive cells. It can cause melanoma. Fort Smith, a peak. South Pole, a peak. Very hard peak. Notice the straight line in the bottom right. But notice in the bottom center, they've changed that McMurdo, which is South Pole, also to the South Korean site. Go back to last night in the video. The bottom center was McMurdo, but it was showing nothing. That was because it has not been recalibrated to match its sister station, also in the South Pole to the right. Notice it 10,050 is its top range, when already its sister station was at 11,300. And then today, notice those spikes. And it's representing over a 3% increase in 10 days around the planet. We're watching this, guys. It's a heads up. I know that was a lot to take in at one time. I had a lot of questions about this. But the things that are affecting our planet are coming from the sun. When we have solar minimum, we're not getting solar radiation, we're getting cosmic radiation, because when we have strong solar radiation and strong solar wind speeds, it creates a stronger shield around our planet. But when the sun's weak, we are easily accessible to cosmic radiation coming in from outside sources. Again, it's a heads up. We're watching it. Be safe.